Brunswick's Superspeed rubber cushions have been the industry standard for more than 70 years. Brunswick has a long history of manufacturing the highest quality rubber for use in its pool tables. The rubber in Superspeed cushions is a proprietary rubber formula that provides the ultimate in performance and consistency in each set of Brunswick rails. Superspeed cushion rubber incorporates a thin layer of cotton canvas, vulcanized into the top and back surfaces of the cushion. This feature results in controlled ball action and greater accuracy in rebounding. Initially, raw rubber, purchased from the Goodyear Company, the same company that makes high-quality tires, is delivered to Brunswick's supplier in the form of large packets. A cutting machine cuts the bulk rubber into small pieces. Because natural rubber comes with many variations and inconsistencies, all Brunswick rails use a specific formulation of rubber compounds. This Brunswick exclusive formula provides a consistent type of cushion rubber over time and from batch to batch. As the smaller rubber chunks are cut, they are stored in baskets and marked as the main rubber component, ready for use in formulating Brunswick rails. To produce a batch of Brunswick rubber, a mixture of rubber compounds is added to a large mixing machine. The mixing machine, called a Banbury, stirs the rubber to an even consistency. A specific amount of red colorant is added to the mixture. Per Brunswick specifications, the color red has been used for many decades. However, any color can be used. After approximately 5 minutes, the colorant is fully mixed and the rubber mixture drops out of the mixer into a basket. The mixture resembles a thick raspberry cotton candy at this point. Next, the mixture is carted and placed in a rolling calandra or mixer. 2 large rollers will force the mixture through the machine and form a thin layer of rubber mixture. Much like how bread dough requires kneading, the rubber mixture requires a few rolls through the mixer to provide an even shape and a consistent formulation. This thin layer will make the rubber easier to use in the extrusion process. A measured amount of sulfur curing agent is added to provide vulcanization. Vulcanization is a process where the springy rubber molecules become cross-linked to a greater extent. This makes the bulk material harder, much more durable, and also more resistant to chemical attack. In essence, this process will give the cushion rubber its resiliency, durability, and ability to hold its shape. The sulfur curing agent must be thoroughly mixed throughout the batch to assure that each portion of the rubber is consistent. A worker must continuously feed the batch through the mixer for approximately 20 minutes until the sulfur is completely absorbed. This is a key step to assuring that each piece of rubber from this batch will have the same physical characteristics throughout the batch. When the composite rubber mixture reaches an even consistency, the batch is now ready to be tested. Each batch of rubber is tested in a rheometer. The rheometer tests the composite mixture's resiliency and consistency. The manufacturing superintendent places a small sample of a new batch of the composite rubber mixture into the rheometer, and a specified amount of pressure is applied. A computer attached to the rheometer accurately measures the resiliency and consistency and provides a report on each batch. If the sample meets Brunswick's exact specifications, the batch can be sent to the extrusion process. In the extrusion process, the raw composite mixture is cut into smaller slices of rubber to enable them to fit into the extrusion machine. Each piece is loaded by hand and is slowly drawn into the machine. The extrusion machine then heats and pressurizes the rubber and forces it through a die in the shape of the face of a Brunswick rail. As it exits the extrusion machine, the hot rubber is cooled in a bath of cold water. Any knots or imperfections in the rubber are trimmed out in this step. If any imperfections are found, the rubber can be recycled and reinserted into the extrusion machine. After cooling, The extruded rubber is then trimmed to the specific size to fit 7, 8, or 9-foot tables. The trimmed pieces are then placed in wooden racks. From here, a cloth resembling a cheesecloth is added to the front of the rails with a solvent. The solvent is placed on the rubber with a sponge, and it chemically mixes with the rubber to create an adhesive. This chemical reaction helps the cloth permanently adhere to the rubber. For Brunswick rails that use Superspeed rubber, the rubber rails are then placed in a wooden rack for the second cloth application step. This step applies cloth to the back side of the rail. This second step of cloth helps provide increased consistency across the entire rail. The only difference between Superspeed and TrueSpeed rails is that Superspeed has cloth on both the front and back of the rail. TrueSpeed only has cloth on the back. A vulcanization press applies 200 tons of pressure at 150 degrees Fahrenheit to the rubber sitting in heavy steel multi-cavity molds. Each cavity is numbered, so Brunswick knows what cavity each piece of rubber came from. This makes it easier to address any potential defects in the mold. Additionally, the press permanently presses the cloth backing onto the rubber. Many of Brunswick's competitors merely glue the cloth onto the top side of the rail, which does not provide the same consistency of bounce across the entire rail. At this point, the Brunswick label is applied and is given the seal of approval from Brunswick engineer Tom Holt. During final inspection, the rails are visually examined and then separated by cutting the cloth and the excess rubber away from each individual piece. The rails are then run through a brief sanding process that removes any bleed-through on the backing or top of the rail. Sometimes bubbles are left in the extrusion process which aren't noticed until after sanding or at final inspection. If a worker sees any imperfections, such as a hole in the edge of the rubber, the worker will reject that rail. Final inspection also includes cleaning with an air hose, date stamping, and packaging. Before each batch is ready for further manufacturing, lab technicians test the rebound performance of a group of sample rails. An apparatus affixed with a weight is dropped onto many segments of the sample rail, and the rebound is recorded. If the rail does not rebound the weight sufficiently to Brunswick's requirements, the entire batch is scrapped. If the group of sample rails from each batch passes these tests, the rubber is then palletized and sent to Brunswick's manufacturer of pool table rails for final assembly.